Hi guys, a very good morning. This is Dr. Sajja Suneel from Data Science Department. Today I am here to discuss about some introduction for IoT physical servers and cloud offerings. What are the different kinds of cloud offerings and what are the different kinds of services which are provided by cloud to our IoT sector? And along with that, I am going to give you a small intro about these IoT physical servers. What physical servers are? Physical servers are the servers where we are going to store the data, and whenever we require, we are going to retrieve with the internet connection. That is what a physical server was. And cloud offerings, what cloud is offering to our IoT sector, what kind of services, infrastructure as a service, platform as a service, software as a service. Like this, there are n number of services which are provided by cloud. Like this, we are going to knowing about these IoT physical servers and cloud offerings in this present lecture, which is majorly concentrating about the introduction to these physical servers and cloud offerings, especially in this particular course called Internet of Things. Now that have a view about these particular things, what the objectives which we are aimed for and what outcomes which we are going to get after successful completion of this particular topic discussion. Let's have a look what are the objectives which we need to focus on this IoT physical servers and cloud offerings which are there. And coming to the objective, understand the exact role of physical servers which are presented in IoT deployment, including the strength, the limitation and the use cases. And also we are going to explore the various kinds of cloud offerings which are available in IoT solutions, such as I already told you, infrastructure as a service, platform as a service and software as a service, and there are n number of benefits which are provided by the cloud. And here you guys need to analyze a successful IoT case studies to identify what exactly the common patterns which are there from case study to case study, and also what are the challenges which are faced in real world and along with the IoT sector in current practices, and the best practices which are there from case study to case study. You guys need to analyze. That analysis will be done successfully in this particular topic discussion, along with the development of comprehensive understanding about different kinds of IoT ecosystems, which includes both hardware as well as software, and along with the cloud infrastructure too. Why? Because this particular topic was purely based on the IoT physical servers and cloud offerings which are provided to our IoT. Let's have a look after completion of this particular course what we are going to get. What was the outcome? You guys are having ability to select an appropriate hardware as well as the cloud platforms for IoT presentation based on the specific requirements. And you guys are improving your skills in designing as well as implementation of these IoT solutions which are leveraging the cloud services most effectively. And also you guys are improving your knowledge on the industry best practices which are going in current trend in IoT deployment structure, and also you are having an capability to evaluate and to propose n number of IoT solutions which are required for the industry. These are the outcomes which we are going to achieve. And now we'll start with an introduction towards this IoT physical server and cloud offerings, guys. IoT physical servers, these are the servers which are the on-ground hardware components which are going to collect the data, and after collecting it is going to process the data from IoT devices. This is what IoT physical servers are doing. In one line, I can say you that IoT physical servers are the on-ground hardware components which collect the data and also which analyze that particular data from the IoT devices. Analyze is nothing but processing the data. Got it, guys? And here the servers which are established, these are dedicated as a part of large infrastructure. And these IoT physical servers are essential for handling the real-time data processing, edge computing, and local data storage. This is about IoT physical servers. And what exactly IoT physical servers are? As I told you, this is an on-ground hardware component which is going to serve as a backbone for the IoT network, where we are going to collect the data, we are going to process the data, we are going to store the data, like this one: collect, process, store. These are the things which are going to be done in this IoT physical server. There are three different types of edge servers. Those types are: the first one, edge servers; the second one, gateway servers; and the third one, data center servers. These are the three different types of IoT physical servers which are existed, guys. Coming to the first one, edge server, which is located and which is closer to the IoT devices, where we are going to handle the initial data processing, which reduce the network traffic and latencies. That is what edge server was. And coming to gateway servers, which are going to connect IoT devices to network, where aggregating the data and also for providing the security purpose. And coming to the third one, data center server. These data center servers are the powerful servers for large scale data processing, storage, and analytic purposes. These are the three different types of IoT servers. And we also need to know about different key considerations which are existed. First one is processing power. This was the first key consideration which we need to keep in mind at the time of IoT physical server. Why? Because this processing power is going to depend on the complexity of the data which is going to be processed. And coming to the next factor, which is storage capacity. We need to accommodate the large volume of data which is generated by the IoT devices. There are n number of IoT devices which are placed in our IoT system. All the devices are going to generate the data. That data has to be stored in some particular point. That is what storage capacity was. We must accommodate the volume of the data which is generated by our IoT devices. For that purpose, storage capacity will play a major role as a key consideration. And coming to the third one, connectivity. Without connectivity, all the devices are useless which are presented in IoT system. So it should be reliable for the network connection for data transfer purposes. And coming to the fourth factor, power consumption. And in this power consumption, efficient power usage is crucial for remote locations. Why? Because whenever you are operating on your current IoT application, you are operating your home automation system, that so and so lights are still on and the geyser was still on and the AC was still on. You are operating by sitting somewhere else. So the power consumption, efficient power usage is required for remote locations. Also, you are able to save the power. And coming to the next factor, security. Robust security measures has to be taken to protect the sensitivity data which is generated by the sensors. These are the key considerations which we have to keep in mind while doing the things in IoT system. Once again, I will repeat in a single word. The first one is processing power. Second one is storage capacity. Third one is connectivity. Fourth one is power consumption. Fifth one is security. These are the 5 key considerations which you guys have to keep in mind at the time of IoT physical servers. Next, have a look what exactly IoT physical servers are. What exactly cloud offering was. We just discussed about IoT physical server, right? Which acts as a backbone in IoT network, which is going to collect the data, which is going to process the data, which is going to store the data. And coming to the cloud will offer a huge huge services, and it gives us a scalable and flexible computing resources for our IT applications, where we are going to handle the data storage, processing of the data, analysis of the data of the applications which we developed. And the major services which are provided by the cloud was infrastructure as a service, platform as a service, and software as a service. Coming to these 3 services, here infrastructure as a service was the first one which we need to discuss. In this infrastructure as a service, which is going to provide you a virtual servers as well as storage, as well as networking resources. We are provided with virtual servers, storage, and networking resources. Coming to platform as a service, where we are going to offer development, we are going to offer deployment environments for a particular IoT applications, guys. That is what about platform as a service. And coming to software as a service, we are going to deliver a complete IoT system as a service. That is what the difference between these three services. In the starting, we are providing only infrastructure like virtual servers, storage, and networking resources in IaaS. And coming to PaaS, we are offering the development as well as the deployment environments for IoT applications. Whereas software as a service, we are delivering the complete IoT system as a service. Got it, guys? This is about the three services which are provided by a particular cloud to a particular IoT industry. Got it, guys? And now we will move forward where we are knowing about these services in detail along with the best examples which are related to that particular service. IaaS stands for infrastructure as a service, where we are offering a virtual servers as well as storage and networking resources, which I already told you. And here it provides a good flexible and control over the infrastructure. And this particular service is suitable for organizations within in-house IT expertise. The best examples for this IaaS was AWS EC2 and Azure Virtual Machines, Google Cloud Engine. These are the best examples for infrastructure as a service. And coming to platform as a service, we are going to provide development as well as deployment platforms for IoT applications. Here the major focus is going to be on the application development and management purposes only. This particular service is suitable for developers as well as organizations without any kind of extensive IT resources, guys. In the best examples for this platform as a service was AWS IT Core, Azure IoT Hub, and Google Cloud IoT Core. These are the best examples for this particular service. And the next one, SaaS, software as a service, which delivers you a complete IoT solutions as a service, which requires minimal IT involvement, and this particular service is suitable for businesses with specific IoT needs and limited technical resources. The best examples are Salesforce IoT and IBM Watson IoT, SAP Leonardo IoT. These are the best examples for software as a service. And coming to the additional cloud services which are presented as IoT device management, data analytics, machine learning, security. These are the 4 additional cloud services which are going to be provided to the IoT sector. And coming to IoT device management, here we are getting a provision for maintaining the IoT devices, and also the configuration and also the monitoring of the IoT devices are done in this particular IoT device management service, where provisioning, configuration, and monitoring will be taken care of. And coming to data analytics is nothing but processing the data, analyzing the data for making a good decisions. Got it, guys? And coming to machine learning, here in machine learning, by taking a predictive model, we are building some predictive models for performing some automated tasks. Got it? That is what a machine learning service was. Along with that, security, which plays a major role. Why? Because we need to protect the IoT data and devices from other threats, hackers, whatever you can call it as. We need to provide some IoT data security and devices from threats. That these are the additional services. And have a look, guys, what exactly IoT case studies are. Along with the IoT physical servers and cloud offerings, we also need to know about the case studies, where the case study, simply you can say it as, which is a showcase for real world applications of IoT technology. With this, we analyze the case studies where we are going to learn about successful implementations and also the potential challenges which are existed and what exactly the insights, valuable insights from the industry trends. And we need to combine these elements for allowing the design, development, and deployment of the IoT systems which meets the specific needs for any kind of organization or any kind of industry, guys. And see here, what are the different IoT case studies which are presented? As I told you, IoT case studies which acts as a showcase for the real world applications of IoT technology across various industries. These are going to provide you valuable insights into the following things. Those are successful IoT implementations, where we are going to identify the best practices and strategies. Got it? And challenges and solutions, where we are going to learn from the failures and we are going to overcome the objects. And coming to business impact, we are measuring the return on investment, ROI, return on investment. We are measuring return on investment of IoT projects. And industry trends, we need to understand the evaluating IoT landscape. Why? Because day to day the IoT landscape was evaluating a lot. So we need to understand the industrial trends and design an application which apts to the current requirement, so that our IoT application will be the most trending application as per these statistics. And coming to the next factor, which is common IoT case study areas. The common IoT case study areas are smart cities, healthcare, agriculture, manufacturing, and retail, and whatnot. And almost all the industries are utilizing our IoT applications in a most effective way. I will tell you some examples which are meeting these particular requirements, study areas. The first study area was smart city. In smart cities, traffic management, waste management, public safety. All these three factors, if you observe, traffic management, waste management, and public safety, all these three factors are the part of smart city. And coming to healthcare, remote patient monitoring, wearable devices, supply chain management. All these are related to healthcare industry. Coming to agriculture, precision farming, and livestock monitoring, supply chain optimization. These play a major role in agriculture. Coming to manufacturing, predictive maintenance, supply chain visibility, quality control are plays a major role in manufacturing. Coming to retail industry, inventory management, customer analytics, smart shelves. All these are a part of this particular IoT case study areas. And coming to this particular module, we are having a good topics which are going to be discussed in our further classes, such as introduction to cloud storage models and introduction to communication API web servers. And in this particular cloud storage models as well as communication API web servers, we are having web server for IoT and cloud for IoT, Python web application framework, designing a RESTful web API, which is application programmable interface. Got it, guys? These are the topics which we are going to discuss. And coming to it, the first one, which we are going to start with, introduction to cloud storage models and communication APIs. What cloud storage model was and what communication API was. Cloud storage model, which refers to different methods of storing the data on remote servers. Examples which include the object storage, like well-known product Amazon S3, for block storage, EBS, and file storage, Google Drive. These are the best examples for the three different kinds of storage models. The three different kinds of storage models are object storage, block storage, and file storage. Object storage, block storage, and file storage. These are the three models. These three models are going to perform different data types and different patterns that we will see in the next slide. And coming to communication APIs, which are set out for programming instructions, which allows us to design different software applications to interact with each other in IoT context, where it's enable the devices, it enable the applications and cloud services to communicate for exchanging the information between those two things. That is what a communication API was, application programmable interface, which allows us to transfer the information between the device and between the other devices for transferring the data. As I told you, and these are the things web server for IoT, cloud for IoT, Python web application framework, and designing a RESTful API. All these are the parts which are presented in this cloud storage models and communication APIs, guys. And coming to the each individual, what web server was, how this web server for IoT it was useful, how cloud was useful for IoT, how a Python web application framework is designed. I will tell you within a short brief what web server was. Web server is nothing but a software application which is going to handle the HTTP request and serves either it in static or dynamic content. The best examples are Apache, Nginx, and IIS are the best examples of web server. And coming to web server for IoT, a web server which is specially designed or configured to handle the unique requirements of IoT devices such as high concurrency, real-time data processing, and security are the factors for this web servers for IoT. And coming to the third factor, which is cloud for IoT. Cloud for IoT, which refers to cloud computing services, which tailored for IoT applications, where we are providing infrastructure for data storage, analytics, and device management capabilities. Along with that, we need to know about Python web application framework, this one. And here, this was a software framework which is going to provide you a structure for building web application, guys, by using our Python programming language. Here, the best popular options are Django, Flask, and Pyramid. By using these three things, we are going to design a popular options by using Python programming language, Python web application framework, which is providing a structure for building web applications, guys. And coming to the designing RESTful web API, what this RESTful web API was, which is a software architecture. RESTful web API, which is a software architecture for creating web services that going to interact with the RESTful constraints. Here also it uses HTTP methods and CRUD operations. What HTTP methods and what CRUD was? HTTP, Hypertext Transfer Protocol methods, get, post, put, delete. And coming to CRUD operations, CRUD stands for create, read, update, delete. C stands for create, R stands for read, U stands for update, and D stands for delete, guys. That is how here it was clearly represented. And coming to the next one, how this design will be done. Here, while designing the things, it involves defining API endpoints, application programming interface endpoints, and HTTP methods, Hypertext Transfer Protocol methods, and also request response formats to handle the errors more effectively while communicating between client and server. And along with that, you need to know more things. While designing any kind of cloud storage, it has to hold the IoT data and communication API for data transfer. Here, if you observe in thoroughly, cloud storage means which holds IoT data, communication APIs which enables data exchange, web servers which manage interactions, Python frameworks to facilitate application development, RESTful APIs to define communication protocol. If you have observed the things, everything is having a unique requirement in IoT industry. If you take cloud storage, we are storing some information. We are holding some IoT data in it. If you take communication API, we are enabling data exchange between client and server. If you take web servers, we are going to manage the interactions between client and server. If you take Python framework, it is giving a facility to develop the application. RESTful API, it is defining the communication protocol which has to be used between client and server. This is the beauty of these things which we had till now. And coming to the next thing, which are cloud storage models. In this cloud storage model, as I told you, there are three different types of storages. One is object storage, another one is block storage, another one is file storage. Coming to block storage, the data is going to be stored in form of objects with metadata, which is ideal for unstructured data such as images, videos, and log files. And here the object storage was highly scalable, durable and cost effective. The best examples are Amazon S3, Google Cloud Storage and Azure Block Storage. What cloud storage? As I already told you, which offers you a flexible and scalable way to store and manage the data. Different kinds of models are there according to its own pattern. If you take object storage, the data will be stored in form of objects with metadata, which allows unstructured data such as images, videos and log files. Coming to block storage, here the data is going to be stored in blocks and in the form of raw information. It is similar to the traditional hard drives where we are having an operating system which boots volume of data and applications of data, where we are providing with low latency and high performance. The best examples for block storage are Amazon EBS, Google Persistent Disk, Azure Disk Storage. And whenever we move to the next storage, which is file storage, here in this file storage, the data is going to be stored in form of files and directories, and it is a little bit similar to local file systems. It is very easy to manage and access the shared file structures. The best examples are the Amazon EFS, Google File Storage, Azure Net App Files. And here the data lakes, the next one, which stores a vast amount of data in native format, which is used for big data analytics and machine learning. The best examples are Amazon S3, Azure Data Lakefront and Google Cloud Storage, which are form of data lakes. And coming to communication APIs, there are 4 different kinds of things: MQTT, message queuing, telemetry transport, HTTP, hypertext transfer protocol, COAP, constraint application protocol, AMQP, advanced message queuing protocol. These are the 4 different types of protocols which are used for exchanging the data between the IoT devices and applications and also the cloud servers. Coming to the first one, MQTT, which is a lightweighted, which utilizes a model called publish and subscribe protocol for IoT devices. Here it is ideal for low bandwidth and high frequency data transmission will be done in message queue telemetry transport. Coming to HTTP, which is widely used for web communication, which can be used for IoT data transfer, and also this HTTPs are suitable for RESTful APIs and web-based IoT applications. Coming to COAP, which is Constraint Application Protocol, which is purely designed for resource constraints and which is optimized for low power and low bandwidth environments, guys. And coming to AMQP, Advanced Message Queuing Protocol. This was the protocol which provides us a robust for enterprise graded messaging and also supports various kinds of message patterns. That is what advanced message queuing protocol. These are the different kinds of protocols which are existed in communication API for exchanging the data between IoT devices and applications. And coming to WebSockets, these WebSockets are bidirectional communication channels for real-time data exchange. And along with that, RESTful APIs. I already told you here it is going to use HTTP methods such as get, post, put, delete to interact with the resources. And also it builds common for web applications. With this, you are knowing the good patterns for communication protocols which are dependent on the data type and the access pattern and also the device constraints and to improve the reliability. Thank you guys. We'll meet in the next class with some more introduction about these communication APIs. That's it. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.